You gotta do the 5. Oh. Good evening and welcome to another edition of what?
TWed.
Is that good? See, now you interrupt. Can we edit that out?
No.
Go. Live.
Good evening, everybody. Another evening of TWed Talks. We welcome back to in our midst,
Back by popular demand.
back by popular demand, for a second talk on csv2rdf or LOD, which I'll let him explain. Ladies and gentlemen, Tim Lebo.
Thank you, Patrick. So as promised, we're back, and we're still talking about the converter. The URL here is bit.ly, Lebo TWed2. Will get you to the GitHub wiki that will walk you through the materials that you can run and execute up until 9 o'clock tonight, or whenever you feel like it, but you will be doing it until 9. For anybody that is out on the web watching this, we'll be breaking down into just programming and stuff. So if you would like us to keep the video feed on while we do that, please tweet me. I am Tim RDF, all one word. So if we get your tweet, then we'll know we'll keep the video live, and we can have discussions if you'd like to. Otherwise, we'll kill the video feed and we'll just do it here ourselves. So what I'd like to talk to you today is kind of revisit the motivation for why we want a systematic methodological architecture for converting tabular data into RDF data. And I'm not going to talk about the quick and dirty, the naive bootstrap that I talked about last time, that's contextualized by the source, the data set, and let's start over now that my iPhone's not chirping at me. The quick and dirty, we're not talking about the bootstrap that's contextualizing by the source, data set, and version identifiers. We've already talked about that. That's in the last video. And we're not trying to convince you that having an incremental approach that allows you to revisit particular conversions, to apply more time and attention to create more well-structured, highly connected, more meaningful, and more interoperable data, RDF data, because we already covered that last time. So what I would like to talk about this time is extending that and talk about the distribution and reproducibility that the converter affords based off of these RDF enhancement parameters. And we're going to return to the farmer's market example that we were working through from scratch last time. We didn't get as far as we should have with that. And so now I'm going to, like those cooking shows, just show you the pie at the very end. And so now you can just push a couple of buttons, run a couple of commands, and you'll be able to reproduce that in the same way. And after you've reproduced it, you can verify it using some Sparkle Query unit tests that are also part of the version control repository. And once we wrap that up with the farmer's market, move on to a new example to point out some new features of the converter, which would be the RPI Research Center example, which we just did put together over the last couple of weeks. RPI administration threw us a spreadsheet and said, show it to us. And so we did, thanks to Alvaro and Dominic and Jim McCusker. Anybody else in that flurry of... Who? Well, yeah, John Erickson. Oh, obviously, he's the one that threw the spreadsheet at us. And then, so just kind of want to reinforce the distribution, reproducibility, and the verification that you get from using this tool set. So, just a quick summary. The problem that we're facing is that a lot of people are distributing data. A lot of that data is tabular, and it's not integrated, it's not connected, so you can't kind of get a holistic understanding of what's there. And so you can contrast this blockhead and this human looking at the unintegrated data set, and you compare that to the human and computer that are looking at the RDF data set, and it's easier to consume the RDF data set. And you contrast that with the data value 15 versus the URI, DBPD's URI for Hawaii, and we can do something with DBPD's URI for Hawaii, but not really much with 15. But how do we get from 15 to Hawaii? We can do that in a variety of incremental stages until we figure out that 15 actually means Hawaii. And the URI design and the automation allows you to incrementally add those new RDF representations that reflect your new understanding of that. And the way we do that is with the tool csv2rdf4lod automation, which is a set of shell scripts that wrap around the core converter. And it's up on GitHub, and you can grab it and you can work with it. And I hope you do, and I hope you get great success with it. What you do when you grab that stuff is work through a variety of integration stages. And what we're picking up today, we don't actually have to go through any of this because we're just going to grab what's already been done and reconstruct the RDF, leveraging what we've already done, what I've already done since the last talk. But the general process that you do, the first is very important, is to name the data set, which is providing identifiers for the source, the data set, and the version, which will then be used to contextualize all of the entities that are ever named, as well as naming the void data set itself, as well as contextualizing the predicates and the classes, the vocabulary that's used to describe the RDF that gets created from the tabular data. Before you've named it, you can name a data set without ever retrieving any data. So after you name it, you can retrieve it, and when you retrieve it, you have a particular version, which represents the snapshot from whomever you obtain the data from. You can optionally adjust that data. Hopefully you don't have to. A lot of the enhancement parameters allow you to work to avoid all adjusting. We highly recommend that you don't manually adjust whatever you get, because then it becomes much more difficult to reproduce what you've provided into the linked data cloud. You create the conversion trigger once, and then you can pull it as many times as you need to continue converting the data. That conversion trigger also gets version controlled, which is one thing that you'll pull down off of the repository this evening. And then you can publish the data directly as the raw data, and you can optionally add in some enhancement parameters that you can then reapply and publish those new layers, which are augmenting monotonic descriptions of the original entities that you created in that original data set. So you're only ever adding new data, and you're backward compatible, and you're not breaking any existing applications that were built against your original data published. Yes?
What do you mean by monotonic?
Monotonic means one hump. You never take away a triple. The triples always ever go in. And so when you never take away those triples, then any queries that went against those triples originally will never break because you didn't take them away. They might stumble into more, but that's kind of the nature of the web. So those are the stages that you go through. The reality that we're dealing with is multiple data sources, which are providing multiple data sets, which provide multiple revisions. And so by providing identifiers for each of those three primary naming contextualizing attributes, we can contextualize the string HI within the entirety of those three contextualizing attributes. And as we gain an understanding of how they interconnect with the other data sets that they share common descriptions with, we can start peeling away those contexts by just shortening up the URI from the end, and we can start integrating in an incremental way. So this URI design, this namespace design allows us to do that incrementally. And like I said, as you start to integrate, you start peeling away these lower levels of the URI. So this thing one, we didn't even know it was a state, and so you take the value up to HI. We now have a URI for HI, but eventually we want to get to the DBPD resource for Hawaii, and so that's kind of the incremental process that we go through when we consolidate entities. And the same process applies for predicates and classes as well. So we can integrate across entities, across predicates, or across classes as we need to. And being able to mix these contexts, here are the different colors of the nodes or the edges will reflect different contextual depths. And we can mix these contextual depths as we see fit and as we need to. trying to bring everything up to a global context so that we are integrated with the rest of the linked data. Quick peek at the enhancement parameters that we looked at and developed last month, I guess. The core of it is basically describing a layer data set, which would be the first enhancement layer, which would oppose the raw data set. We have the 3 primary contextualizing attributes, and then we just point to the conversion process and list out a variety of enhancements. And so the game to play is to assert these enhancements within this template to alter the behavior of the converter, to guide how it should be interpreting that tabular structure into well-structured, highly connected RDF representation. So the important aspect of the enhancement parameters is that it is RDF, and so we can use that to describe how we want to interpret that tabular data. And it only needs to be created once. And once it's created, you can share that RDF representation, and it can be reapplied to similar tabular structures. And so we're allowing anybody that consumes our linked data to also backtrack and be able to reproduce it from source on their own. And so that way we're able to provide some transparency into the linked data that we're providing. So, Greg, I fixed the example that you had, as you pointed out, my dyslexia. So here we have the original tabular, a single row that's wrapped just to fit onto the slide from one of the DataGov data sets. We go through a naive raw conversion that doesn't get us much more value here. The value actually comes from whenever we enhance the data set. Here we're using a variety. Every predicate that we're creating or we're using here already exists. We're using W3C's personal information management contact vocabulary. We're using DC terms, RDFS, OWL, W3C's Geo, WGS. So all of this can be consumable by a variety of systems on the semantic web. Whereas you contrast that with what we're looking at here, no system is going to really be useful. You're going to have to kind of squint at it and figure out what's going on. So that's where the value comes in. And that value comes out of applying that interpretation that's encapsulated by these enhancement parameters. So I've already talked about the declarative enhancement parameters. That's useful. The really nice thing about this is that it's a common transformation terminology across data sets. And so it's very, very small, very concise, and it's analogous to RDFS. So as we talked about last time, we talked about domain names and range names. You're actually referring to analogously the RDFS domain and RDFS range, and we're minting a class for you. So a lot of the enhancement parameters, if you're familiar with RDFS, you'll be able to pick up on these enhancement parameters quite easily. Because it is a small, concise description, it's easier to inspect once you're familiar with that vocabulary how that tabular structure was transformed by reusing the notions that RDFS provides. And there's no software tailored to these specific data sets. So the same terminology is applied across all domains. You're not writing kind of one-off implementations that transform some particular structure into RDF. You're reusing the same transformation widget that's guided by the same terminology. And the really nice thing, because it is RDF, you can then query for data via how it was actually transformed. That's advanced. That there's an example on my wiki, and if you're curious, let me know afterwards. We can talk about that. So let's dig into the finishing up the example that we had last time with the farmer's market. Before we dig into that, does anybody have any questions? Then we're going to make some awesome RDF. Okay, so who has the converter installed? That's a weak. Is that kind of? Is it kind of installed? Or
Say it's installed, not installed.
move this way?
You cannot go any further to your left than that.
This is as far left as I can go. Okay. All right. So, I will hop you up to the bit.ly. Load up this bit.ly to get to the GitHub page. That will point you to the commands to run.
How do I start this thing in the first place?
Start what
I
thing?
mean, I ran it like a month ago. Last
Okay. Well, so if you're revisiting it, then all you need to do is source the source me. That kit comes out whenever you install it, and that just sets up the home variable so that it knows all of where all of the executables that are part of that package are. So go to the directory that you cloned it, or did you grab the tarball?
I have no idea what I did. Maybe I'll just watch it today.
Ah.
What directory is
And so, does anybody need this URL? That everybody has this? I see no's. Let me know when you have it. You don't need it? Okay, so you're at that page? Okay. And so if anybody's watching the stream, tweet me at TimRDF, TIMRDF, if you're interested in having the video feed stay on and following through the tutorial. If not, I'm guessing we're going to kill it to save bits and people's time. Okay.
Bits are cheap these days.
Yeah, I guess. But not people's time. They want to watch the last half.
They're watching it live and they can pause it, watch it later.
Alright. So we're good with this URL? Alright.
I tweeted it, so just check for TWed talks. Hashtag, and you'll be able to get that URL later on.
So if you're at that page, after reviewing what I just talked about, outlining what I just talked about, I list out the 7 enhancement parameters that we actually talked about last time. And the first thing we tackled was a header row, because the header row is on the 5th row, and so we just pointed the converter to the 5th row. We did a symbol interpretation combination that basically omitted empty string triples to clean up the triple count for things that aren't useful. We set a domain name to farmers market. We set a comment for one of the predicates. We set a range for, I think, state. We set a range name for state, and we did a links via for state as well. And the next code snippet is the first default template that the automation provided to us. It poked into the CSV, looked to see what the headers were, the column headers were, and then created this default template for us. The snippet after that is the enhancement parameters that we ended up with. And so the 7 that I just outlined, there's a header row here. We say that the 5th row is a header row. We paired up the symbol in interpretation to say that if you see an empty string, just consider that to be null and don't output a triple, because triples with empty string objects generally aren't useful. We have the domain name, where we provide just a literal string. This is where it's different from RDFS. In RDFS, when you say a domain, you're specifying a URI for another class. In the converter, we haven't created the class yet, and so we just specify the local name, and we create a URI out of that during conversion. And then we focused on 3 columns. We focused on the state column. We added a conversion comment that would manifest an RDFS comment on the predicate that does get created. We changed the range to an RDFS resource, which it was an RDFS literal. We set the range name to state so that the URI that was created from that cell was then typed to an RDF type to state within the local namespace. And then we LOD linked using the links via triple predicate to point to a variety of LOD link files. Bigger. Wow, okay. And along with the links via comes the subject of, and if you dig up any of these 3 LOD link files, you'll see the DC terms identifier sitting within that. And so, we see here Alabama has a DC identifier of AL. When we see AL in our spreadsheet, we then know that there's a same as relationship between DBpedia's Alabama as well as the Alabama that we just created. And then we passed the values of 6 and 7 to decimal and overrode the property to be equivalent property, because we already know that they're latitude and longitude. We don't want to reuse or create a new property within our local namespace because we know that they are WGS Latin long. So if you compare the first template to the second template, that's what we did. That's what we finished with at the end of the month, or at the end of the time last month. And then the next 2 snippets are the raw RDF that comes out before enhancement, and then the second snippet is the enhanced RDF that we ended up with at the end of the day. We ended up, this is a little bit better because we have, the rows are typed, they're typed to farmer's market. We have Hawaii here as a URI instead of just a literal HI. And I think further down we know that Hawaii is the same as GeoNames, GovTrack, and DBpedia's Hawaii, so we're actually tied into the cloud. And we have WGS Latin long typed to decimal. So we're a little bit better than the raw, but we're not as good as we could be. And so the first thing that I'd like you guys to do is get to where get to as good as it could be without going through all that effort. And so as good as it could be is the same farmer's market. So we're just augmenting descriptions to the same row. It's still typed to farmer's market, but it has a contact address to a new URI for an address. It uses DC terms title instead of whatever predicate it was before, and then WGS Latin long. And then for the address, we have the street, city, and zip, and a reference to the actual state. And then the state being same as the other entities. So the first goal is to have somebody create this RDF. And this wiki page documents the design on how this is done. You don't have to read it now because we're here to walk you through it. But check this out after the talk. And these are the commands that would get you to reconstruct that RDF from scratch. So the only prerequisites here are to have the converter installed, because retrieve sh has a dependency within the converter. So if you haven't converted it, or if you don't have the converter installed, we can get that installed. And if you do, then we can try to run these commands. Who's giving it a shot? All right. Patrick?
What?
Lead by example.
Damn it.
I mean, if we want, I can walk through everything, call it a night, and then we can just sit down and do it. What are people interested in seeing?
More efficient.
Okay, so just walk you through what would happen if you care. Okay. Okay, so these 4 commands. What you're doing here is Patrick.
If it complains about the certificate on e-signs, just send it to accept.
We totally trust Patrick. So there's another wiki page on the GitHub documentation that describes how to use version control with the converter automation, and what we're doing here is basically version controlling the data root skeleton, which only version controls the essential minimum that's needed to reconstruct the RDF that we're producing through the LOGD project. And so we're hosting that data root skeleton on our eScience machine, and I will load up that URL. And you'll run into a Subversion web page that says, "Hey, there's an RQ and a version directory. The RQ directory contains the unit tests to be able to verify the conversion after you've created it. And in the version directory are the 2 essential bits that you need: the retrieve.sh and the eparams.ttl. The retrieve sh just has a URL that points to the file to retrieve to create a new version, and the eparams.ttl are the params that I just pointed you to. Right, so we've got the header row 5 and the equivalent property, contact, state, or provenance. So when you SVN check out that directory, you're going to get those files. And you go into the version directory, and I mean, I guess it doesn't. Is anybody interested in seeing me do this right now?
Mm-hmm.
Well, okay. All right. So I'm going to copy the first command. I'm going to go to my home directory, and I'm going to make the directory, and I'm going to go there.
Well, I don't know, before you do this with the whole thing, do you kind of show the highlights like in your wiki page anyway?
Yes, that is the... Yes, so the wiki page talks about the results and shows you what you would do. So,
I don't know, it might be more useful just to do it off of this page.
okay, so you go into the version directory and you run the retrieve. That's going to go grab the data. It's going to see that it has the enhancement parameters. It's going to apply those enhancement parameters to that data, and it's going to create the enhanced layer of that data set. And it's going to create it within a version, because you have to name the version using today's date. Today's date? Yes. So, well, yeah, let me just run it because it's
Okay.
easier to poke into. So I'm running these things. So I downloaded all of the stuff from SVN, and the directory's not there. I'm running the retrieve script, which is grabbing the data file off the web. It sees that the enhancement parameters are there and it's applying them, creating the RDF into the automatic directory. It's downloading it into the source directory. So we have a new version, so we go into that version. And we see within our conversion cockpit the source directory, the manual directory, the automatic directory, and the published directory. And the automatic directory is going to have the RDF the good RDF. And you can check that out. So, great, we grabbed a data file, we applied some enhancement parameters, but how do we know it's any good? How do we know that we didn't mess something up? How do we know that we created something that the whoever posted that data, the enhancement parameters, wants us to actually see? And so that's where we can actually unit test the conversion. And so we unit test it from within the conversion cockpit. And so we're just telling the unit tester to set up, which will create a TDB endpoint, and we're asking it to be verbose to show us the Sparkle queries that it's applying. And so it's loading the TDB directory with the data files that are in the published directory, which are also on the web. And I fail. 0 of 2 passed. So that is because I am very cautious, because I work on so many different projects and so many different domain names, that this is a good segue to the CRVARs. But if you type in CRVARs, it will print out all the current state of all the shell environment variables that it uses to control the automation on whether or not you're going to publish. Are you going to publish to a Virtuoso endpoint? What's the URL of the Sparkle endpoint? Do you want RDF XML? Do you want N triples? Do you want Turtle? And so if you just run that script, it'll have a hierarchy of variables. And at the very beginning of that is the base URI, which is the URI of the project that you actually work against. And there's also a URI override that you can use if you're testing a deployment. So that even though in the enhancement parameters it'll put the base URI as logd, you can override that to be on a different domain so that you can deploy your data as linked data onto a different domain to test it before you actually deploy it on the final domain. And so I'm cautious because I work on so many different projects, and so I just have to unset that variable. Reconvert by pulling the conversion trigger. And so the reason why those 2 tests failed is because all the URIs were within the localhost namespace, and the tests are designed against LOGD namespace, and so they break, which is good because if it means that I shouldn't have published the data, or I didn't, but that I should not publish the data. So now I can test by loading the TDB directory again, and then applying the, and still failing. I hope this one works. Wow. And then we passed.
So what's TDB?
TDB, triple database. It's from Jenna. Tuple database. It's part of Jenna. But it's really straightforward. You can just point TDB to a directory, point a TDB loader to a bunch of RDF files, and then it'll take over that directory and create index files. And then once you have the index files, then you can point a Sparkle query to a query thing and point it to the directory.
So you don't actually have to put it down on the web.
Right. Yep. So you can just. Yep. And then once you have it in a TDB directory, you can then expose that as a Sparkle endpoint on the web. So yeah, I'm not sure why that's failing. Oh yes. I hope this one works. All right, moving along. Right, and so next on the web page, I'm just showing you the test output where it actually does pass 2 of 2. And once we publish it, we can do magic like Alvaro does magic, use LOD speaker, and create a demonstration that shows you can query by zip code and get the, I think I can just click on this. No, I didn't. So it asks for a zip code. And he has a pointer here to the, on the lower left, to the URI for the data set that we're using. And that falls back into LOGD. We do the search. And he's using LOD speaker here to craft the templates to be able to point to the 3 different farmers markets, as well as have a Google map. Whoa, alright, Alvaro. Wow. So I clicked on one of the farmers markets, and it still points it to a map, and I guess this is from DBpedia, so information about the state. So he used the URI that was in the enhancement layer to query into DBpedia to find out information about the state. So, thanks, Alvaro. So that finishes up the farmers market example using the enhancement parameters and the unit tests that are version controlled up in the data root skeleton. You can reproduce it from scratch. You can point to the source's data set, retrieve it, and run off and do what you want with it. Now we can move on to the RPI administration research center demonstration. We got a spreadsheet from RPI, threw it into a Google spreadsheet, and click on it here. And they have the name of the research center, which I didn't realize at the time that I converted it. So I need to create another enhancement layer. The amount of money that they spent. So here, $9 million for biotechnology interdisciplinary studies. Variety of lists of faculty that are in that, that are associated with that center. Different thrusts that they pursue, different schools that are involved, and interesting for this example is they have a single cell that breaks down the distribution of funding. So the funding can be corporate funding, federal funding, other funding, state funding, or a gift. And so this is where we're going to use cell-based enhancement to create n-area relationships that conform to the RDF data cube vocabulary. And so, and we also have this problem where we're mentioning multiple people in multiple cells. And so there's some consequences when you promote those to URIs that they don't actually consolidate. And so we can use a template, a domain template, a range template to actually consolidate those. And LOD link them for that matter. So going back to the example, that's the source data set on the Google spreadsheet. We also have the version controlled data root here on the same SVN, where you start falling into the same. Here's the unit tests in the RQ directory, and here's the version directory, which has 2 cached versions, as well as the retrieve, the pull directly from Google, and then 2 enhancement layers that are applied to the same data. The E1 does not do cell-based, and the E2 does cell-based. And that's the typical pattern that we fall into, because it's easier to create an enhancement without cell-based than it is to, until you realize that it needs to be cell-based. And so the website shows that example.
So you're saying you're going along and doing your enhancements and stuff, and then you realize that there's more than one data point represented by a cell.
Yeah, you realize that they start representing statistical data, and when you realize that, generally the enhancement 1 that you've created has already been deployed. Applications are already built against that, and so you can't go back and change enhancement 1. So you make enhancement 2 that just lays on more triples on top of the same research centers. And I can show you so these are the commands that you would run to go grab our data set off of Google, apply our enhancement parameters, both layers, and go in and then test it. And when you test it, you'll end up with 5 out of 7 passed. That's intentional because we have 2 things that we need to fix. And so this is the nice thing about having unit tests, is that we know they need to be fixed. And we just kind of threw those in during the development so that we keep getting these constant reminders that we're failing certain tests. So it's a lot easier to look at it on your local machine, but enhancement layer 1 looks like this, and we have a research center with a _5. We have 2 references back to the original data set that is using DC terms and void, hoping that we've increased our audience, so that some people recognize void in data set, some people recognize is referenced by. And so all of the rows point back to their data set so that it's linked, and you can find more information about what you want. We know that research center is a FOF organization, so we use a subclass enhancement here that is talked about later in this process. And I mentioned when we were looking at the spreadsheet that multiple columns mention people, and they're all talking about the same bucket of people, the same RPI people, and we want to just kind of collect all of them all at once. And so the enhancements actually have them all fall into just being FOF members, and then they're individually typed to different roles. This isn't this is kind of a quick and dirty role representation with a few assumptions, but it all depends on how you want to model it. And so this To Ming is typed differently than this David Duquette, based off of their role within this this data set.
So where are they typed differently?
They're
Those 2 lines look the same.
right. So yeah, they're not typed here. They're just mentioned here. The Research Center member To Ming, Research Center member David Duquette. And if you look further down in the turtle file, they will be described themselves. They'll be types to person, they'll have a DC identifier, an RDFS label, and they'll be typed to some local name for chair or faculty or something else. So the flow of the turtle output file follows the flow of the main components of the CSV, and the ancillary stuff kind of gets shoved down to the bottom. Or if you're following this as linked data, then you just click on it and find the types. And so here we have the corporation as just one big string, and we also have it in individual cells on the spreadsheet. And this is where we start to realize that we should be modeling this with a cell-based subject, or a statistical modeling, or an RDF data cube modeling. Because the problem here is that if we tack on, really we're drawing an association between the percentage of funding, the type of funding, and the research center. And if we had a new kind of funding, then we would have to create a new predicate to draw that association. And casting the funding type into a predicate makes it difficult to handle multiple funding types. And so really that should be an entity that's being referenced by a generic predicate. And that's what the RDF data cube actually allows us to model. And so if you run this, if you pull a conversion trigger with a -E2 flag, it'll convert the second layer. And we get a change in naming for the subjects. We have a 5_14, which is telling us that it's from a cell instead of just from a row. Before we were _5. And so we've got an _14 and we've got an _16. And so now we have a URI behind each one of the cells, now drawing an association up to the header, over to the research center, and then out to the actual value. And what that's doing is pulling up this 3-area relationship that's associating the research center, the funding type, and the RDF value. There should also be a MUO measured in, but and when we add a new funding type, we can generically process this 3-area relationship without having to change any of our Sparkle queries, or having crazy Sparkle queries that just have variables in the predicate. So compare those two on the web page. It's hard to get all that on the screen at one time, but you now have a new resource that's drawing the 3-area relationship between those 3 values. I already pointed out the subclass of. The domain name is typing the row, and you specify a literal string for the type. During conversion, a URI gets created for it, scoped within that full context of the source identifier and the dataset identifier. And the subclass enhancement just pairs up the local class that hasn't been created yet with a superclass, and just saying that the research center is a subclass of flow of organization. And we materialize the inferences with that, so that the research center is of type local research center, and it's also of type FOF organization, which I pointed out. And we can see here, it's a FOF research center, and it's a FOF organization. We talked about LOD linking last month. Here we're talking about people across 4 different columns. And so we can say that the predicates at 4, 9, 10, and 11 are linked via some URL. That URL is actually a Sparkle query into our LOGD endpoint that queries into an instance hub, one of Dominic's instance hubs, named graph, to select all of the DC identifiers for people. And I mentioned that because we had people across different columns. For all 4 of these columns, we're overriding the default URI construction to follow this pattern. Variables are encapsulated by square brackets. They get expanded during conversion. The slash expands to the base URI. The S expands to the source identifier. The D expands to the dataset identifier with a slash. And then this literal typed person, and then the current value of the cell. And so no matter what, by default, the URIs are scoped by the predicate, the columns that in which they're mentioned. But we want to consolidate across all 4 of those columns. And so no matter what value is mentioned, they get placed into that URI namespace. And so we're able to consolidate across all 4 of those columns. And after we've named those URIs, we look for same as relationships from the LOD link file that's generated dynamically from the Sparkle query into the instance hub named graph. And the expanded query, so the URL encoded up here within the LOD link file is this. So this is the query that we're getting to find people, their identifiers. I guess we weren't using their names. And then we're just constructing person identifier ID, and then this is what we're using to LOD link against after we've retrieved the results of the query. So I've already talked about the CRVARs. Just run it and it'll show you all the environment variables, changing those variables, change the behavior of the automation, turning on certain components, turning off other components. The publishing, once you've done the conversion, the publishing is done by invoking a variety of scripts within the publish bin directory, and each of these scripts is tailored to that specific data set that you want. So if you want to load into Virtuoso, you just run that script and it'll load it into Virtuoso. If you want to delete from Virtuoso that named graph, it'll delete it. If you want to link it to the web to expose all of your dump files, your input files, you can do that as well. And all of these are created after you've run the publish script, and the publish script uses the environment variables. It constructs all of these scripts and then uses those environment variables to decide whether or not to run them. So you can turn everything off when you do the publish and then just make it happen by running the scripts within the bin directory. And so when you publish a data set, where does it go? So there's some design, actually almost a no-op design, that required us to decide the association between the void dataset hierarchy, because there's a lot of void metadata within our conversions automatically. But there's an association between, so during conversion, this is what we're saying about those data sets. We're saying that there's an abstract data set which accumulates many versions of the data set. And that abstract data set is identified by the source identifier and the data set identifier. So here we have the research centers data set. That's an abstract data set. We can name that before we actually obtain any data. On October 17th, when we actually retrieved it from Google, we had a version. And any RDF that is a consequence of that retrieval is all those triples are part of this void data set here. We did the same thing the day after. Once we did some of the cell-based enhancements, modified some of the, cleaned up some of the data in the spreadsheet, we had a second version. We captured that, we cached that. All of the triples that fall out of that are a part of that void data set. And then the one that I just created today is also a version data set. And all 3 of these have a data dump that gets you directly to an RDF file that allows you to just get all the triples. And that's what the void vocabulary is for. So once you have all of that void hierarchy and metadata, you have access to the data dump that corresponds to each of these versions. The URIs that correspond to the void data sets correspond to the URIs of the named graphs within our Sparkle endpoint. And that can be demonstrated by showing this insert. So insert the data dump file into the URI for the version data set. And it looks like I'm wrong here. I have an October and November. So if you know the URI of the data set, which falls out of knowing the source identifier and the data set identifier, then you also know where it is within the Sparkle endpoint. But you don't have to think about how to do that because the automation, the publishing scripts already have that baked into them for you. And so for the templates, there's a page talking about the templates, and I already pointed out the templates being used to consolidate people here. And the templates page lists out the different variables that are available to construct different URIs using the column value, the cell value, the column number, the property name, things like that. Some operators to lowercase to uppercase and things like that. So that's the end of the overview. So I'm guessing we should probably kill the video and then dig into running through any of these examples locally. But before we kill the video, are there any questions?
Wondering how you handle the case when people, they've got all these happy days scattered around these different columns. What if they put different names?
They do.
I'm sure they do.
We handle that with Instance Hub. So, so here I'm saying columns 4 through 11. I'm going to override how the URI is constructed, and the URI is going to look like this. And then after I've created that URI, I'm going to request this file from the web, which happens to be a Sparkle query into an endpoint, our local endpoint. And I don't know if I can pull that up. It's going to be probably pretty ugly and really long. I like my white space. But you're going to request this. It'll come back as an RDF file. And in that RDF file will be instances of FOF person. And those FOF people will have DC identifiers with their names. And so for the example that we had with the research centers, in some columns they mentioned their middle name, middle initial, and other columns they didn't. But there's only one Professor Carruthers in the computer science department. And so in the Instance Hub, which is also sourced from a spreadsheet, a Google spreadsheet. Oh no. So the same process of grabbing a spreadsheet, converting it to RDF, and hosting it up on Sparkle endpoint is the same process that we use for Instance Hub. And so once we publish it into the triple store, there's a named graph for people that has their URIs and their DC identifiers, and that's just hanging out. When we go through our process to process the research centers, we LOD link to a file that happens to be querying into that named graph that returns that RDF file that says person identifier, and then when we're enhancing the research center data set, we do the LOD linking that we see that those labels match up, and then we assert the same as.
So that's where the human comes in to say, John Jason is the same as John Jason.
Yeah, so the person comes in here where here we got Jason Volin. Jason is Jason O. Volin and Jason Volin. And the one URI that he has is just the Jason Volin. We've got Jim Hendler using his actual DBpedia URI instead of a URI that was created locally. And so this data is just, this data set goes through the instance hub process, which is about curating associations between URIs and the labels that we care about for the things that we care about. So, Dominic, what things do we care about?
We care about states, agencies, physical years for some reason. I would say the one toxic chemicals, and I'm blanking on the fifth one. Chemicals. You really should know this. Oh, produce, or
Produce?
crops.
Crops. So there's a few things that we care about, and there's a few things other people care about, and they can kind of curate their own list, and it's a marketplace of LOD link files, and anybody that creates an enhancement can point to any one of those LOD link files and manifest the same as associations that they want. So this table goes through the same conversion process, ends up on the same endpoint or any other endpoint, and then whenever we do the enhancement process on the research centers, whenever we create our people for research centers, we're pointing to what looks like just RDF that associates people to identifiers, and then we're LOD linking it locally and then producing that in the enhancement.
So, is it kind of like a lookup table where you?
Yep, exactly. Yeah, so there's no heuristics here. Everything about the converter is you tell me what to do and I'll do it. If you want to apply heuristics, you can do that on top of what I've done, or before. You point me to the results of heuristics, right? So if you want to do kind of a string distance thing, then do right. Then do a string distance thing. Produce that as a LOD link file that I can then point to. But at the end of the day, I'm just gonna string match, case insensitive or sensitive, depending on what you want, against what's there, so that it kind of modularizes what we know and what we don't quite know. Yeah. Anything else? Alrighty. Well, thanks.